Okay, so here's what we're going to do today. We're going to deal with paired t-tests. And paired t-tests are very, very common. A lot of times they're used to decide, like, is a treatment working? So the treatment that we have today is that we had 11 subjects and they took these caffeine things and then they tracked, like they took these caffeine pills and then they tracked their depression systems, and the higher the score, the more depressed they were. So we can see the depression of caffeine, and we can see the depression from if they got the placebo instead of the actually caffeine tablet. And so they want to see is like, does caffeine really affect your depression level? And so, like if you don't have your caffeine, if you're barred from your caffeine. So our assumption is that it doesn't. We're going to assume that it doesn't work, that our mean would be the same. Like this and this would be, this value and this value would be exactly the same. What we would hope that would happen is that they're not the same, that our means are not the same. Because if our means are not the same, that means that this caffeine pill works, and that if people are barred from the caffeine that they take, that they would be more depressed. And so here's how we're going to go about doing this. We're going to check these lists. We're going to check the difference in the score. So we're going to take this score on this side, and we're going to subtract it from this score on this side and see what result that we get. We're going to probably put this in the calculator because that's a little bit easier to do. So I'm just going to go over to my list, and I'm going to put, well, I probably should put the higher values in. So 16, 23, 5, 7, 14, 24, 6, 3, 15, 12, and 0. Then I'm going to go to this other list over here. Put these in. 5, 5, 4, 3, 8, 5, 0, 0, 2, 11, and 1. And let's see the difference. So that's going to be our list 3. So we're going to take our L1 minus our L2. And there we go. There we can see the difference. Now it would be nice to know what the mean and all this stuff is of this new data set that we have. So we're going to go to our VARS. Oops. We're going to calculate our VARS stat, so we're going to go over there. And then we want to make sure that it's list 3 that we're calculating. And we can see for this data set that our mean of our sample, or the difference that we find, is 7.6, I think. Yeah, 36. And that looks like it's significantly higher than 0, but we still have to test this. And so we want it two-sided. Let's give our alpha value, let's say our alpha value is 0.05. So that would be a 2% range here, or a 2.5% range here, and a 2.5% range over there. And let's see if it falls outside of that 2.5%. So again, we're going to use, this time, we're going to use a t-test because all the data that we have is samples. And so for a t-test, you can find that t-score by doing your mean that you found minus your actual mean, which we think our actual mean should be 0. And then you take the standard deviation, which the nice part is our calculator did that. And we want the sample standard deviation, so that's 6.91. And we do that over the square root of our sample size, which is 11. So let's figure out by the calculator what that would be. So 7.36 would be the top. Divide that by 6.9 divided by, or multiplied by, or nope, divided by the square root of 11. Hopefully this works out. And so we can see that our t-score would be 3.5. 0.537, with the degrees of freedom being, we had 11, so the degrees of freedom being 10. And we'd have to look that up on our chart. So let's go find that on our chart. So we'd go over here to 10 degrees of freedom. We look for about 3.5 something. So right there. So it looks like it's a little bit under 0.25% of the time. So it definitely is outside in this range. Our p-value is very, very small for this. So our p-value for this thing that we just found would be 0.0025, which is definitely smaller than the alpha value that we were given. So this thing, we would reject the null hypothesis that people that take placebo, like that caffeine has, like if you have had caffeine and you stop taking caffeine, that you aren't more depressed. You definitely will be more depressed, and you'll score higher on the scale because of our p-value. So that's how the pair test works. You take the values in this side and you subtract them from the values in this side. The other nice thing is your calculator can do this test for you with relative ease. If you go to the stats and you go to test and you go to a t-test, because we aren't given the population, and you just go to data, what you'd want to do for the data is you're just going to go to list 3, because that's where we put the things. Our assumed mean is 0, and we're saying that we want to see that it's not equal to, and then we just hit calculate. And as you can see, it calculated it for us. Its test statistic is pretty similar to ours that we found, and its p-value is a little bit more accurate than we can get with this table, though. So, because the closest we can get to the table is that, but we know that we got a little bit higher, so it's in between there, and we can find that with the actual value that it's a little bit under 0.5%, but we would still reject the null hypothesis with that value. So that's, again, the big thing with the stuff today. These are the paired distributions. You're just going to take this list or the new list minus the old list, and a lot of times you're hoping that the result is that they're the same and that they don't change. So your means a lot of times will be 0. Make sure for this you're not using the 2 statistic t-test. Like, we're not using 2 different statistics for this. We're figuring out the difference and seeing if the mean difference is the same or different.